Okay, today we're starting Unit 5 on quadratic functions. And the first chunk of this, section 5.0, is actually review. It's things that you would have been taught in Foundations of Math 10, and you probably don't remember most of it. So we're going to go over it again, all right, just to refresh your memory. All right, we'll start with some basic vocabulary. Math is often about looking for patterns and relationships between sets of data. We call any comparison between two sets of elements a relation. In previous courses, you've represented relations in many ways, such as words, an equation, a table of values, a graph, a set of ordered pairs, or function notation when that's appropriate. So let's review these. Example 1. Consider the relationship between x and y. In part 1, or example 1 here, the relation is defined by the equation 3x plus 5, and the relation defined by the equation y equals x squared plus 4. What difference do you notice between these two equations? Well, the thing that I want you to notice here is that this first one is an equation of degree 1, and the second equation is of degree 2. Now, we're not going to worry too much about degrees in this course, other than the degree is the sum of the exponents on the variables in a term. Okay, the highest exponent in this is got a little 1 there, and this one has got a 2 there. So that's degree 2. Oops, degree 2. All right. And that has really important implications to what the graph, to what it looks like. So let's fill out a table of values for this. So I'll do this nice and formally to remind you of how to do this. So I like to write over here y equals 3x plus 5. And then what we want to put in this space here is what does y equal if x equals negative 3? So I do the calculation over here. This is 3 times negative 3 plus 5. So 3 times negative 3 is negative 9 plus 5, which is negative 4. So I'll put the negative 4 in there. In this one, it's going to be 3 times negative 1 plus 5. So that's negative 3 plus 5, which is 2. I invite you to pause the video for a minute and do the rest of the calculations in this column on your own and check that they're right. I'm just going to fill them in. And over on this column, on this table, do the same thing. Y equals x squared plus 4. So I'm going to plug in my value for x, which is negative 4. Now remember your exponent rules. This is going to be really important here. This exponent of 2 is applying to everything in the brackets here. So that's going to be negative 4 times negative 4, which is 16, which then I'm going to add to 4, which gets me 20. Okay, if I have x squared and my x equals negative 4, that does not mean negative 4 squared, okay, because negative 4 squared written that way is negative 16. It has to be negative 4 in brackets because that whole thing needs to be squared, and that's positive 16. That's a really important distinction. And don't necessarily trust your calculator on it. Don't trust it blindly because some calculators actually mess that up. So you've got to be really careful with that. All right. For this one, this is going to be negative 2 in brackets squared plus 4. Negative 2 in brackets squared is 4 plus 4, which gets me 8. And again, I invite you to pause it and fill in the rest of the table on your own. Okay, let's go on to the next page where we're going to graph these. So I've just copied the results from those tables for you here, so we have them all on the same page. So negative 3, negative 4, so my x comes first. I start at the origin, I go 1, 2, 3, and then I'm going to go down 4, 1, 2, 3, 4. So this point right here is negative 3, negative 4. I have a point at negative 1, positive 2, a point at 1, 8, point at 3:14 and at 5:20. And then I need to put a line through those. So when you draw a straight line, it's really important that you do it as precisely as you can. Oh, I want to change the color of that. Oops, sorry. Okay, when you are drawing a line, you want it to be as precise as it can be, and you want the points that you're connecting to be as far apart on your graph as you can, because that does give you a more accurate line, more accurately positioned line. And then either you extend your line all the way to the edge of your drawing, of your grid, or you put arrows on the end of it. Okay? All right, so there's our straight line. Y equals 3x plus 5 is a straight line. It's degree 1. Degree 1 will give you a straight line. Okay, this one, I have negative 420. I have negative 2, 8, 0, 4, 2, 8, and 4, 20. Okay, so this is a parabola, and the easiest way to draw a parabola, which I can't demonstrate on this, you draw a better curve when your hand is inside the curve than when your hand is outside the curve. So I would draw this side. Whoops, that was bad. Okay, I would draw this part. That was bad. Let me try this again. It's hard on here. I would draw this part. That was pretty terrible. And then I would actually turn my paper, and I would do this one from the other side. Watch this. This is going to be better. It shouldn't have been better. Okay. I haven't got a magic trick without. There's some tools you can get that can let you do really nice curves, but just make sure that you're going through the point and make them reasonable. My right side is not reasonable. My left side, yeah, kind of. Okay. You want them to be reasonable. The important thing is placing the points. Okay. All right. How are the graphs similar? They can both be drawn as one continuous line. Can both be drawn as one continuous line. How are they different? One is straight. One is curved. All right. Some other vocabulary that you should hopefully be familiar with at least is the domain of a relationship is the set of all possible values which can be used for the input of the independent variable. And the independent variable is x. So domain, that's a B. Let's try a D. Domain is possible x values. So the domain of the graph on the left is, well, this one can be any real number because any number you pick for x is going to have a corresponding y value. The arrows indicate that it goes on forever, so it continues up and to the right forever, and it continues down and to the left forever. So the domain for this we express as x. And then this is a funny E that looks like that. It's like a curve. It's very curved, like a C with a line in the middle of it. And then R. This is called a double struck R. It's you put 2 lines for the upright, and it stands for the real numbers. All right, I'll make notes on that in a minute. The domain of the graph on the right is the same thing, because as this goes up forever, it is going to the left forever. It's going to the left much more slowly than it's going up, but forever is a long time, so it does keep going forever and ever. So it does encompass all of the numbers to the left and all of the x values to the right. So the domain of this curve, of this parabola, is also all the real numbers. So x, e, r. So that's all the real numbers. Oh, what is with my B's and P's today? Numbers. All right. The range of a function, or of a relation, sorry. The range of a relation is the set of all possible values which can be used for the output of the dependent variable, or y. So range is the possible y values. Okay, get that in your brain, because we're going to be using that all the time through this unit, all right? All right, let's state the range of the straight line graph. Well, the range is also all real numbers, because it's going up and down forever, right? So we're going to write that as XER. Okay, and then I'm just going to detail what this means. This funny E means is an element of, and the funny R, the double struck R, is the real numbers. And the real numbers is basically all the numbers that you know, okay? If you can write it as a number, it's a real number. If you can write it as a number, it's a real number. There are things that are not real numbers, but you don't know them yet, so don't worry about it. State the range of the graph on the right. Well, this one is a little bit different, because can y be 0? Can y be down here? No. There's no place where if y is 0, there's a corresponding x value. If y is negative, there's no x value for it to, there's no point where it can be. It has to be 4 or greater. Any y value of 4 or greater, yeah, you can go and you can find an x value that's on the curve. So if you keep going way up here, if you're 5 million or something, if you go over to the right, you will find an x value that corresponds to it, because this curve keeps going up and up forever. But it cannot be less than 4. So we're going to write that, and this looks really funny. I'll explain it in a minute. Okay, we use the curly brackets to denote a set. And this is y. And then this line right here, this means such that. That's how we read that. Okay. And then this is the part that's really necessary. And you need both parts of it. Okay. The answer, the range of the graph, is y such that y is greater than or equal to 4, and a comma which says and. Y is an element of the real numbers. So in this case, the range is all real numbers that are greater than or equal to 4. Okay, and you need both of these. Okay, because you could have one that's all the integers that are greater than or equal to 4, or all the even numbers that are greater than or equal to 4. That could be the range of your graph. So you have to say that it's all the real numbers that are greater than or equal to 4. Okay? All right, next page. Relations versus functions. A functional relation, or a function, is a special type of relation in which each element of the domain is related to exactly one element of the range. If any element of the domain is related to more than one element of the range, then the relation is not a function. Yeah, say what? Okay, the easiest way to think about this is looking at a graph. There's something called the vertical line test or the pencil test. And if we were in class, I'd hold my pencil up or a yardstick or something in front of this. So I'm gonna have to draw my pencil. This is gonna be sad. Okay, so here's my pencil. Okay, so I want you to imagine that I'm moving my pencil across the graph. So over here, on the left side of it here, if I hold my pencil up there, it only intersects my graph in one place. That's okay. This part could be a function. But if at any point on my graph I can put my pencil up there and it crosses through 2 points, this is no longer a function. Okay, this is not a function. It's still a relation, but it's not a function. Okay. How about this one here? If I hold my pencil anywhere I hold my pencil along here, I'm only going to cross the graph in one place. So yes, this is a function. All right. This one here, this is not a function because almost anywhere I can put my pencil and it crosses in 2 places, so it's not a function. Okay. I'm going to give you a minute to actually try those. Or why don't you pause it? I mean, you pause it, try it, and then come back and check your answers, okay? All right, how'd you do? Okay, it's not a difficult concept, but it's just one more piece of vocabulary that you need to be aware of, okay? All right, linear and quadratic functions. A linear function is a function whose graph is a straight line, like that example we did at the beginning of this section. A quadratic function is a function whose graph is like a U shape opening up or an upside down U shape opening down. And this graph is called a parabola. So let's go through and identify each of these as linear, quadratic, or other. So I guess we should draw them first, shouldn't we? Okay, so I'm going to draw these, but don't worry about how I'm drawing them, and don't worry about being super accurate in how you copy them down, because that's not super important at this point. Just try and do them approximately what mine look like. You know, make sure that they're pointing in the right direction and the curves are kind of in the same place. That's supposed to be a straight line. That's supposed to be symmetrical. Okay, now I think the easiest way to do this is with a highlighter. So I'm going to highlight in blue all of the equations that are linear. So that means they're straight lines. So this one's a straight line. This one is allegedly a straight line. There we go. Those are the straight lines. And then the ones that are parabolas, let's do those. I'm going to do those in pink. So that one's a parabola, that one's a parabola, that one, and that one. And then I will do some in yellow. I think this is yellow. Nope, green. All of the others. Okay. They're not parabolas and they're not straight lines. Okay. So can you see something that all of the quadratic equations, all of the parabolas have in line, or have in common? Well, hopefully you can see that they are all polynomial functions with degree 2. All right. I'm not worried about you seeing the polynomial functions. Those are funny words. But degree 2, that's the important thing. So this has got degree 2. This has got degree 2. This has degree 2. It's the highest of all the terms, and this one's got degree 2. This has got, which one? This one's the, it's in the exponent's in the denominator. That doesn't work. This is a degree 3, so that doesn't work. This one's a degree 3, and that is a degree x, so that doesn't work either. Okay? All right, continuing on to page 6. So this whole unit is about quadratic functions. And a quadratic function is a function which can be written in the form f of x equals ax squared plus bx plus c, where a, b, and c are all real numbers. Okay, that's what this is. A, B, C are elements of the real number set, and a is not equal to 0. And that's because if a equals 0, then this term disappears and it becomes a linear equation, bx plus c, which is what you studied last year. This is what we call function notation. And this is equation notation, or equation form. And the only difference between the two is that here we have y and here we have f of x. And the difference is it's just a notation change. You only use f of x if your equation is actually a function. Equation form you can use for things that are not functions, okay? Don't worry about it. It's not a really important distinction for you for today. Example 4, which of the following are quadratic equations? Well, this one, we have a equals 2, b equals 0 in this case because we have no x term. But yes, this is a function, or sorry, this is a quadratic equation because it does have degree 2. This one is not because it's got degree 5. And this one it's just written in a different order, okay? We could write this as f of x equals negative 1 over 5 x squared minus 2x plus 3. And these are completely equal, right? I just changed the order things were written in. So this is a quadratic equation. Example 5, which of the following graphs appear to represent quadratic functions? Well, this one does. This one not, because it's not a function. It's a parabola shape, but it's on its side, so that doesn't work. It has to open up or down. This one, yes, and this one, no, because this is also not a function. Okay. Example 6. Parabolas have either a maximum or a minimum point. Identify this point in these graphs. Okay, so here, right here, this is our maximum, and you always need to say if it's a max or a min. So here our max is at negative 4 and 5, okay, because that's the coordinates, negative 4 and 5. This is also a max, and it is at 12.6, so be sure that you are reading the scale on your graph. If there are no numbers on the graph, you can assume that it's 1. Each box is a 1, but always check to see if there's something written on your graph. This one has a minimum because this is the minimum value that the graph ever reaches, and that is at negative 9, 0. And this one also has a minimum at 1, 3. Right here. Okay, all right, that's it for the review part of this. So go back to your first page of this package, this work package, or sorry, of the notes package. The work package is separate this time, and do the assignment on pages 325 to 328. Do all of the questions in there. Okay, make sure you check your answers, and then write the quiz and all that good stuff, and then come back for lesson 5.1. Okay, actually, I'm not sure there is a quiz. Never mind, there's no quiz for that. just do the homework because that stuff you're now assumed to know. All right? Have a great day. Bye.